Today I'll be explaining a new reactor system which is being commissioned by ILS. We were contracted by the Technical University of Clausthal, one of our oldest clients. We originally started working with the group of Professor Turek roughly 10 years ago in Fischer-Tropsch units. Synthesis gas applications. They've approached us again for a synthesis gas unit. In this case we're looking at methanation. This is a pulse methanation unit, which is used for doing transient studies on methanation catalysts. The background of the project is that methanation is a novel way of storing hydrogen in the form of methane as an energy transfer or energy storage medium for storing renewable energy. And the real goal of this project is to see the steady state activity of methanation catalysts over time, how they behave. And in principle, in this system, we can age methanation catalysts in an accelerated manner. And one of the most unique things about this unit was that we have two different reactor types. We have a so-called continuously stirred recycle reactor. It's an internal recycle reactor on this side. The advantage of an internal recycle reactor is that it makes possible kinetic testing under so-called integral reactor conditions. So high conversion levels, which are more indicative of what would actually happen in a large-scale process. This is a unique reactor system which ILS has actually licensed in from the University of Erlangen, developed in the group of Professor Wasserscheid over the course of about the last 20 years. It's a novel internal reactor system which can spin at very high stirring rates, up to 10,000 RPMs, and has the real advantage of being able to generate genuinely gradientless conditions of temperature and concentration in a reactor, even at low pressures, which is often very challenging because of the low density of gas. So here we can test the catalysts under integral conditions. On the other side of the reactor system, you'll see we have a fixed bed reactor system. On the left, the fixed bed reactor system is operated primarily under differential reactor conditions, meaning we're operating at very low conversion levels. The advantage of the differential reactor system compared to the integral recycle reactor is the simplicity of the reactor. We can also operate with long isothermal reactor zones here, as opposed to having a short, a thin, broad catalyst bed in the internal recycle reactor. One of the keys of this system is that the system is made to operate under pulse reactor conditions. So what we do is we switch the synthesis gas on and off repeatedly over time in order to simulate basically the formation of or the inclusion of hydrogen coming from an electrolysis unit during day and nighttime cycles. For example, if you're looking at hydrogen generated from solar power or from wind power. Again, the whole idea being to look at how methanation catalysts behave over time if they're continuously oscillated between reactive and non-reactive conditions. It's a fully automated unit and has a so-called recipe control system which allows it to be operated 24 hours, 7 days a week, fully unattended. This is a very unique system in that there are two different reactor types integrated. Another reason ILS was chosen was because we are an existing supplier for this client, and this is basically repeat business based on the fact that we have delivered systems in the past which have worked very well, and we have a very close interaction and collaboration with the group of Professor Turek in Clausthal.